In this lesson, we're going to take a look at relating place value to multiplying and dividing by powers of 10. And this is standard 5 NBT 2. In the previous lesson, we took a look at the number 7,777, and we noticed that even though it's made up of sevens, the digit 7 has a different value for each place it's in. And we furthermore noticed that when you're moving to the left, the value increases in terms of multiplying by 10. So it actually goes up by a power of 10 each time. So as you're moving from left to right on the place value chart, your value decreases in terms of dividing by 10, or a power of 10. So today we're going to take a look at kind of a shortcut in multiplying whole numbers by powers of 10. So our first example will be exactly what you see here. We've got, let me extend the page here. Well, I'll move right on the side. Maybe that'll be a little better. So we've got, for example, 7 times 10 to the third. As a little review, we'll just show that exponents, the 3 up here, really tells us that we're going to multiply this 10 by itself 3 times. So it's 10. Oop, I don't think that 10 looks like a 10. Let me rewrite those for you so they're clearer. So we've got 10 times 10 times 10. So it really, you've got a multiplication symbol in between those 10s. Put it in a different color so it stands out. So you've got 10 times 10 times 10, and you're thinking to yourself, okay, 10 times 10 is 100, and 100 times 10 would be 1,000, and yeah, you'd be exactly right. So 10 to the third power equals 1,000. So 7 times 1,000, and you're probably thinking to yourself, well, I see it over there, and you'd be exactly correct. Yep. You would, oop, popped in there for us. The 7,000 would be the same as saying 7 times 1,000, because it is in the thousands place. Or you could say 7 times 10 to the third would also equal 7,000. So you notice that you're like taking, whoops, I wrote with the wrong pen there. So you're taking that 7 and you're tacking on 3 zeros behind it. So 7 times 10 to the third, you'll notice we added on 3 zeros. Now I also want to show you something in terms of decimals, or the decimal point. We've got the same problem. We've got 7 times 10 to the third equals 7,000. We know that now. But look what happens to the decimal point. So we've got 7, and look at the 7 itself is moving to the left. 1, 2, 3 places. And if you notice, that decimal point appeared to move to the right. Well, really, the decimal point stays to the right of the ones place for all time. But anyhow, the decimal point appeared to move to the right. Let me show you again. Watch that decimal point. Even though the 7 is moving to the left, it's increasing in value by moving to the left on the place value chart. Look at that decimal point. 7 times 10 to the third, so it's 3 places over. 1, 2, 3. That decimal point appeared to move to the right 3 places. So a lot of times you see that shortcut taken. We've got 7, and to the right of the ones place always would be the decimal point. And to the right of the decimal point are numbers less than 1. Anyhow, so if you look at this, you've got the decimal point, and since it's times 10 to the third, so 7 times 10 to the third, the decimal point appears to move over 1, 2, 3 places, so it would no longer be there. And you could fill in these zeros for each space you moved to represent, or kind of hold those places. Sometimes people say they're placeholder zeros, but anyhow, you could see that that decimal point really moved. I don't think I can separate that decimal point, but anyhow, the decimal point moved to over here. It seemed to move 3 places to the right, giving us 7,000. So yeah, we can really use that as a shortcut. I mean, we'll go over some examples in just a minute. But before we do that, I want to take a look at what happens when you move to the right on the place value chart. Say you had, I'll put the example right on here. Say instead of 7 times 10 to a certain power or elevated to a certain power, say you had 7, whoops. So say you had 7 divided by 10 to the third. And we noticed that as you divide by a power of 10, moving to the right, you're decreasing by 1/10, right? I mean, you're decreasing by a power of 10, but what I mean to say is that if you were to look at the hundreds place, or this place up here, the hundreds place, the hundreds place is really 1/10 of the value of the thousands place. So you're decreasing in value. So now how would we show that here with the decimal point? Well, let's do the same thing that we did earlier. We've got 7 divided by 10 to the third. Okay. The number itself is getting smaller in value. Okay, so watch. 7 moves to the right 3 places. Did you notice that? Now we've got a decimal. We've got 7 hundredths. But take a look at the decimal point at that time. It appears to move to the left 3 places. So you found out that that is equal to 7 hundredths. So let's write that in there down here. There we go. 7 hundredths. So the 7, so that same digit 7 we were working with, is now in the hundredths place. So it's worth 7 hundredths. It's decreased in value quite a bit. So the shortcut, since that decimal point appeared to move to the left, is just probably what you're thinking. So we've initially got that 7, with the decimal point immediately to the right because it's in the ones place. Now we've got the 7, and what do we do with this decimal point? Well, the decimal point appears to move to the left 3 places. And just like we did before, we had these placeholder zeros here. And in essence, you're looking at seven hundredths. You can see it right there. So that would be a quick shortcut. So now that we know that, and it's all because our place value system is based on 10, you can use that little trick when you're multiplying by powers of 10. We're going to take a look at this. We've got this worksheet. You can go to worksheetsandwalkthroughs.com and print this out if you'd like. We're going to take a look at these 8 problems. Now, let's take a look at the directions first. It says, directions: use your knowledge of the place value system to multiply or divide whole numbers and decimals by powers of 10. So the first 4, you're multiplying by a power of 10, and the last 4, you're dividing by a power of 10. So let's take a look at this first one, 7 times 10 to the second. So let's use that shortcut we learned based on the base 10 foundation of our place value system. We've got the original number we're working with is 7, and you're multiplying by 10 to the second power. Remember what I said about that decimal point? It appears to move to the right 2 places. And you would have to fill in those placeholder type zeros, and you would be getting an answer of 700. And there it is. Quick and easy. But really, it's good to understand why you can do that. Again, it's because the place value system is based on powers of 10. It's a base 10 system. So let's try the next one. We've got 42, 42, and we're going to multiply by 10 to the third power. So you can always count that decimal point to be right after the, or to the directly to the right of the ones place. So there it is. And we're going to multiply by a power of 10. So that decimal point appears, like I said before, appears to move to the right 3 places. So now we can put those zeros in there. And your number would be, oops, looks like a 6 there. The number would now be 42,000. So that would be your final answer. 42,000. If you were thinking that, good for you. You know, if you want to pause the video anytime, you can go ahead and try these on your own. We've got, in this case, I'll move a little bit quicker now, 9.5, and we're going to move the decimal point 4 spaces because we're multiplying by a power of 10, or 10 elevated to the 4th power. So now we'll do that. We'll move that decimal point over 1, 2, 3, 4 places. The decimal point would land here. Remember, it appears to move, but actually the numbers move around it. Anyhow, so you've got this number. You start at the decimal point, count 3 over, and put in your comma. You should rewrite it. That would be 95,000. Next example. We're starting off with the decimal 300ths. You could also think of that as 3 cents or 300ths of a dollar. And we've got, we're multiplying by 10 to the 3rd power. So you're probably thinking, okay, that means that decimal point appeared to move 3 spaces over to the right. We'll put it there and now fill in that 0, giving us, well, this, remember, this decimal point would not be there. So there we go, get rid of that. So now we've got 3 in the tens place and 0 in the ones place, otherwise known as, or AKA, 30. There you go. Probably getting the hang of this. Good for you. Now you've got 57 divided by, kind of changed operations on us, and it's divided by 10 to the 2nd power. So remember, when we were dividing by powers of 10, that decimal point seems to move to the left 2 places, and it would now land here. So we're looking at 57 hundredths. That's the answer to that. You're probably thinking that. Good for you again. And we'll try this one. We've got 1 in 62 hundredths. Our operation symbol is division. So we're dividing by 10 to the 1st power. So our decimal point would, let's change colors. Our decimal point would now be located here. If you look at that and rewrite it, it would be 162 thousandths. Number 7, we've got 4,352 divided by 10 to the 3rd power. Decimal point appears to move 3 places, indicated by this 3 up here, that exponent 3. Now the decimal point is located here, giving us 4, excuse me, and 352 thousandths. And the last problem. We've got 3,452,921. Decimal point after the ones place, always. And then we're dividing by 10 to the 5th power. So we got some movement of that decimal point to the left. You guessed it, 5 places. And relocating right there between the 4 and the 5, giving us a new number of, there you go. And that would be the final answer. So there we had it. We looked at relating place value to multiplying and dividing by powers of 10. Thanks for checking out worksheetsandwalkthroughs.com, and we'll see you again next time.